Hello everyone. In this video, we'll be learning about GDB. Even myself don't know much about GDB, but I have to study it for a test. So here we are. Let's see what a GDB is or what GDB is. So Control Shift T. In Ubuntu, you can always add MAN, that is for manual, and GDB or whatever tool name you want to read description about. Enter. So GDB is GNU debugger. The purpose of a debugger such as GDB is to allow you to see what is going on inside another program while it executes. So that is pretty much self-explanatory. All those who want to know more can read it, but I'm not like the kind of person that reads much documentations. So let's first create a program. As it says, a debugger, as it says, I don't know what it says. Okay, a debugger allows you to see what is going on inside another program, so we'll need to at least create a program. Let's create demo.cpp and hash include stdio io stream, that is input output stream, using namespace std int main cout. This is a demo program and it return 0. So that's a pretty basic program, but the main focus of this video is not on this program. It's based mostly on creating an output file and then like debugging it through GDB. So whenever trying to compile a file, a C++ file, will be using G++, that is the tool, -G to tell G++ that we want to debug it later on using GDB, and -O to generate a output file named demo, and then the name of our main file that we want to compile, that is demo.cpp. Let's hit enter and hopefully it should work. Yes, it did. Demo, and this is a demo program, so everything is working as expected. But let me first create a make file. All those who don't know make file can look at another can watch another one of my tutorial on this page only, this channel only. And like let's see whether a make file is running properly or not. Yes, it is, and demo is working correctly. Yes. Now let's get to the main focus of our video, that is GDB. To run GDB, we just write GDB, enter, and to quit it, we just write Q, enter. Clear. Let's see it again. To run GDB, we just write GDB, enter, and to quit it, we can also write QUIT, quit, and yep. So these were the first two commands that you would have learned by now, like GDB and quit. To run any file, we just write GDB space the file name, that is the final generated file, that is demo. Always try to execute an already compiled output executable file. Never try to run a .c extension file through GDB. And yep, here we are. Here we'll try to run it. So the command for run is yep, it's run, run. And as you can see, we'll see here in the output, run, starting program, and then your total path of your file. This is a demo program. Inferior one process ID executed normally. Even if you're not able to understand what's written there, it's not like quite important. You will understand it as soon as you start to write all these commands, and the more you keep on looking at code. Now let's see the important part of our program, that is breakpoints. So that's pretty much the basic thing about GDB, is that you can set up breakpoints, and using these breakpoint you can like check it. You can pause your program at any point, and like you can run your program from that exact point, or check the variables at that point of time in a program. So you will see what I mean just now. So we have just wrote two more lines. This is a line, this is another line. Let's try to run it again using GDB. Let me first like close my terminals. I already have a lot of terminal opens. Open. GDB demo, enter. I run it and I see this is a demo program. I forgot to compile it. So make, enter, and now GDB demo, enter, run. So as you can see, a whole file is running. This is a demo program, this is a line, this is another line. I'll try to run it again, but this time I'll be setting up breakpoints. To set breakpoints, just write b space and then main, that is the name of the function where you want to set breakpoints. So we have set breakpoint at main. So whenever you write run, enter, that means if the program starts running, as we all know, it starts to run from main. So whenever we write main, the program starts executing, and here in the beginning of main it stops, and this is the line where it had like where a breakpoint had occurred. Let's write continue. Once you hit continue, all of the until another breakpoint is reached, the file will the code will keep on executing. So this example doesn't much explain about the reason behind breakpoints and how it is gonna help you, but just a basic example. Now you will see why it is useful and how we can use breakpoints for our benefit and know how the program is running. So there's one more command, that is L. When you press L enter, it gives you 10 lines of code, and it provides you some input, some view into the code, so you will be able to see in a better way like how the code is running. So to set breakpoints, you can also write b space. Let's say you wanna keep a breakpoint here at the 7th line, enter 7. Yep, let's try to run it again, enter. Breakpoint 1 at main. This is the demo program, that was the line that was to be executed, but we reached a breakpoint. Continue. So you can see this is a demo program and this is line. These were the lines that had been executed. When we reached line 7, we reached another breakpoint, and continue, enter. Here our program did exit. So that was like not much, we haven't done much other than setting breakpoints, running it and stopping it, but it's of no use. Like, what would you even do by setting up breakpoints if you're not able to look into the code? So let's set up some variables. Int I is equals to 0, int j is equals to 47, and yep, I is equals to 47, j is equals to 7, and I don't know why I'm always using 4 and 7s. Like, I is equals to 6, j is equals to 4. Let's see if now we set breakpoints, are we able to read something new from this program. Clear, make GDB demo, and B main, I'll enter. Let's set breakpoint at yeah, as you can see, when you press L, that means you're gonna get 10 lines of your code. If you wanna see more, you'll have to press L, enter again and again. So that's something you need to know. Don't just give up after 1L. Let's set up breakpoints at line 7, 10 and 13. B7, B10, B13, and run it. So at line 5 you reach your first breakpoint, that was due to this B main. Let's enter, continue. Here at line 7 you see you have reached your second breakpoint. At this breakpoint we wanna see what's inside this program, so I'll just write info locals, enter. You'll see that we have some local variables I and j, with I with value 0, j with value 47, and let's hit continue. Now we have reached line 10, info locals, enter. Here you can see I is initialized to 47, j is initialized to 7. Let's hit continue again. You will see info locals. So you will be you can check the value present at any with any variable when using GDB for debugging. So whenever you are getting some wrong output, you will be able to know at what point of time in your program did the value of variable changed. So that's better than guessing. And let's see what more is available with this. Other than writing info locals, you can also do print I, that provide you with the value 6, or you can say print j, this provides you with the value of 4, that is the actual value of I and j, as you can see here. And let's see whether we can change its value. P I is equals to 4, yes, and info locals, yeah, we have changed the value of I, that was previously 6, to 4. Let's try it again. P j is equals to 96, enter, and info locals, yes. So that's one more command. You can like stop your program execution at specific point of time and it change its value. And let's try to make a more resourceful program and then try to see how GDB is helpful for us. let's like remove this and int factorial is equals to 1, int num is equals to, let's say, 6, and we'll be writing a basic program for factorial generation. I hope I don't have to explain it. I'm like, int I is to 0, 1, I is less than num I plus plus. For now we won't be taking care of whether the logic is correct or not, cause even if it is not, it's good for us cause we'll be able to debug it later on, and if it works then also it's good. Like, who would like to spend his time on debugging code? So factorial is equals to factorial into wait, that's not how factorial is generated. So while num is greater than 1 and num minus minus, yep, that's it, or at least I hope that should be it. And factorial. This program should be giving us a factorial. Let's try to run it again. Quit, and no, continue, enter, program ends, quit. Yep, let's clear screen and run our make file again. gdb demo, enter, and L, enter. Now let's set a breakpoint at line 8, so we'll be able to know what is the value of factorial and num after every loop. So we'll just set a breakpoint at B9, enter, and run. Yep, we have hit our first breakpoint, and let's info locals. So num is 6, factorial is 1. Let's continue and info locals. So here you will see num is 5 and factorial is still 6. Yeah, so num is reducing and the value of factorial is 6. Let's continue it again and info locals. It's gonna be tedious task for now, but let's hope. So 30, that is 5 into 6, 30, and the remaining number is 4. That would be taken, that would be like provided to the loop again, so we will be able to get a 4 factorial now, and then multiplied by 30. Continue, enter, info locals. Yep, continue, info locals, continue, info. Okay, yeah, for the final time we continued, the program exited printing 720. Okay, so 6 into 5 into 4, yeah, 720. So we are getting in correct output, let's look into a few more features of this program. Let's try to create a function for factorial finding, and we'll create a function int factorial, and let's say int fact return fact. Let's remove this part and it will be so I'm not doing something new, I'm just like wait, so I'm not doing anything like new, I'm just like shifting this part of code into another function, so whenever we need a factorial we can just write we can just make a call to that function, and you will see how functions are placed in a stack. Let me like first complete this code. So let's remove this. Num is 6. To find its factorial, we'll make a call to factorial 6 and handle, and let's see whether this compiles without any error or not, and it did. Oh, not make demo. The answer is 0. So that's like a good opportunity for us to like debug this code. We haven't like, let's not waste our time in analyzing our code. GDB and demo, enter, L, enter. Let's set a breakpoint at line 5, that is this point, or maybe this while. There's one more way to set there's like B and 8. So whenever we'll enter this loop, we'll know that what are the problems we are facing, and we'll get the local variables and all that. So let's hit run, and we did hit our first breakpoint, that is inside that while loop, and info locales, so fact is 0, and yep, I understood what my problem was. Fact had to be initialized to 1. Initially it had the value 0, so it didn't matter how many times I tried to multiply it with num, the final answer was always 0. So I'll have to provide it with an initial value of 1. But just for the fun of it, let's try to run it again. Continue it, enter, info locales, fact is still 0, continue, enter, info locales, fact is still 0. You might have noticed one thing, that whenever we press info locales, we just get the detail of this function. So all the local variables of the current function, and that does not, in fact it, yep, and that does not include these variables, cause these are provided through arguments. One more funny thing to see here is when you see when you write bt, you can see these two lines, factorial num4 at demo cpp8, and this in main at demo cpp16. You need not like stress much over it, because you will see that in this nothing much is happening other than we will be able to see how the call to function is being stacked. As you will see just now, after this program had ended, continue, continue, delete. Delete is a command that deletes all the breakpoints in a program. Yes, delete all the breakpoints. Continue and hit enter. So we have reached the end of our program, and this is the output 0. So two new things you would have seen by now, that is BT, that is backtracking or backtracing. I'm not like sure what is its full form. And the second thing is delete. So till now we have just learned how to set breakpoints, but just now you saw how to delete breakpoints. There's one more thing to do, that is clear. No breakpoints at this line. Actually, clear is also just like delete, but clear just removes a breakpoint in a specific function. So if you are inside factorial and you write clear, then you would be deleting all the breakpoints of this function. That was like just some new information for you. You need not memorize it. Int demo function, and we'll be just like providing it with some useless code, because we need to know what BT does and how to see its output. It's awesome to be a part of a program. And let's make a call to this through this demo function, enter. And there's one more thing, int factorial, int enter. So we haven't done much other than declaring one more function and making a call to that function through this. And why had we created this useless function, you will see now. In fact, let's create one more useless function, int totally useless. And see out. I am doing my best. Let's make a call to this, see out. Sorry, totally useless. Let's like control C, void, void. So you will see we have the definition of two functions. We have like wrote three functions and a main function. Main functions make a call to factorial, factorial make a call to demo function, and demo functions makes a call to totally useless. Let's try to compile this. Let me quit and clear. That's a clean terminal. GDB, not GDB, make to compile this, and it did run without any error. Let's try to run this demo file, and it is awesome to a part of a program. I'm doing my best. 0. Yeah, great. So GDB demo, enter. see L. When you write L and then a number after it, then we'll be able to see all the lines after that number. Then L again, then L again. So here we have our source code, and I want to keep a breakpoint before and after every call to a function and at the start of every function. So let's start it this way: be totally useless, enter. Be demo function, enter. Be factorial, enter. And B main, enter. Now let's see what do we have here. Continue, run, enter. First breakpoint at line this, and bt, enter. As you can see, we have just the main function here in our stack. Let's write continue, and we hit another breakpoint at this line, so bt, enter. Now you will see we were initially in the main function, then we reached factorial function, so it is placed above that on stack. Let's try to continue it again. Here bt again, you will see that there's nothing to be seen. Continue, enter, and why are we coming back to line number 19? So, up, maybe there are breakpoints somewhere here, so that's why. Clear, deleted breakpoint 3, great. Continue. So here you did see an example of clear. I just wrote clear and we deleted breakpoint 3. That was at line 19, and here is line 19. Continue, bt, enter. So you will see we were in main, then we made a call to factorial, and from factorial we made a call to demo function, and the more calls you make to another function, everything is kept in a stack. So when you will be moving back, we'll be backtracking it from demo function to factorial, and from factorial to main. So in that way the program the GDB keeps a stack of all the calls made. Continue, enter. I'm doing my best, yes you are. And bt, enter. So we are in totally useless currently, and at this specific point, at this specific address, you will see demo function waiting, and at this specific address you will see factorial waiting, and at this specific address you will see main waiting. Continue, enter, and yep, we have reached the end of our file, but we still haven't removed our error cause the result we are getting is 0. So int factorial is equals to 1, and let's not make any calls. Right, clear, gdb demo. And okay, I need to like make to generate the output file. So gdb demo, enter. Let's run our program with breakpoints at basic code, breakpoint at line say 19. And you can also see all your breakpoints with info breakpoints. You will see all the breakpoints you have kept: name, type, display, address, and what, and its number. So it's breakpoint number 1. Let's try to run our program. There's one more way to move forward while working with breakpoints, and that is next, and next, 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 next. As you can see, we are moving one line after one line, and at any point I can say info locales factorial is 30. Next, so factorial is equals to factorial info locales factorial is still 30. Next, info locales factorial is 120. So next, or continue. This is a really clear. All of you did see how this work. I need not keep on enter. I need not show you again and again how to use next or continue. So we saw two ways to run a program from a breakpoint, that is next and continue. Other than next, there's one more command called step, and that's pretty much it about GDB. Thank you.